covered most of the big modules now. Let's look at the delay, hold, clock, and envelope. This is a 4-in-1 module. The job of the delay is simply to delay a gate or CV. Now let's take this signal and then press play, listen to that, and let's delay the same signal and send it to a different drum. And now they are lined up again. With the time input, we can modulate the time with another number. Okay then, and next we have the, let me check, the hold module. So the hold module will take a gate signal and extend it for this duration of time. If I take something like this 16, and we will be able to hear this clearly with a sustaining sound. When I increase the hold time, the sustain will gradually increase. And this too can be modulated. And next up is the clock divider. This will take a clock signal and just divide it, which sounds like this. And again, this sounds pretty good when you modulate it. Let's try this on the kick drum instead. Oops. And so the envelope will create a falling value every time that it receives a trigger. Let's trigger this voice continuously. And then feed the envelope a trigger. When we bring this out to the pitch, the output is only naturally going out by 1, so we have to multiply the envelope's output by a specific number to get the maximum value of the envelope, which sounds like this. And then we can extend the envelope's duration. And we can trigger the envelope slower. And we can extend the range of the envelope. And what do we do if we want the envelope to go in a different direction? Well, we can simply feed its output to the invert module. And now we will be do not invert that, then it will sound like this. Moving on to the MIDI input, this module is mostly self-explanatory, though there are a few little tricks to it that we will go over. This will take a MIDI message from the outside, like from this key step, and convert it into pitch gate, velocity, mod wheel, and pitch bend messages. Now what we can do is take a gate signal directly from the MIDI input, as well as the pitch, and then when play is engaged, then we get MIDI. Now there's one quirk. Do you see how the notes don't line up? It is always one note behind. We fix this by turning on recursive correction in the settings. Now, also in the settings is the pitch bend range, and, well, that is also quite self-explanatory. Now, let's take a look at some of the other inputs. We have a velocity input, and a CC1, which I will use over here. Now CC1 is your mod wheel, and if we plug this in, the mod wheel is now controlling the frequency of the pulse wave, which is directed to the hi-hat. And next up, the pitch bend. And last is the play output. This outputs a 0 or a 1, depending on the state of the transport. So when transport is off, this is 0. When transport is on, this is 1. There are a number of things you can use this for. Personally, I like to use it to randomize some values in the sample and hold. When I press play, then you see the random output. This could be good for modulation, for example. Will output a new value at every new start. This can also be fun to use with the MIDI clock mode, which, look at the transport when I play a note. The transport engages, including if you had some clock in the mux, the sequencer, sample and hold, the clock triggers. Okay, that is the MIDI clock mode. Let's turn it back on to host. And that is mostly everything that this module does. There is a transposition or offset slider for the MIDI pitch. Now, something I like to use the pitch out for is transposing sequences. So if I press play, I have a chord. I can take a pitch message and I can use this to transpose my entire sequence or just select notes. You may be wondering, why did I use the pitch inputs instead of the scale offset input? Let's look what happens when I transpose the entirety of all of our voices. The drums are gone. That's because this DRM1, its kick drum is tied to pitch 36, which is why sometimes it is going to mess up your project if you were to offset all notes equally. In that case, it's the exact same thing, just to go directly to their pitch inputs. Next up with our MIDI input modules is the Arpeggiator. Now, this Arpeggiator is super fun. It allows you to create really dynamic and wild sequences. It's not your typical up-down multi-octave arpeggiator. Rather, the way this one works is, if you look at the voice number right here, is this gives you 8 voices, which you can enter a sequence of notes into. And then the up-down counters will count through those voices, with the trigger being forwarded to the arpeggiator's gate output. So to enter notes in, you've got to play legato, and now I've played a sequence of notes that ascend, and the counter is counting upwards through those notes. However, if I enter a pattern of notes, we can count through those quicker. What happens when I count down is I count down through that sequence of notes. It's like if you have a step sequencer that you have forward and reverse playback options. And what the offset does, let me enter. What this voice input does is it offsets the playback position. So if I enter 3 here, it will count upward from the 3rd voice, and it will restart again at 3. And you may have heard that this can scan through the voices manually. If I remove the clock, it can actually sound quite granular. And what's really interesting about this arpeggiator is when you combine the up, down, and voice input triggers to make one long, crazy sequence. So now let's turn up this DRM1 and start addressing some of these arpeggiator voices. Next up of the big modules is the sequencer. This is a 16-step sequencer. The length can be adjusted with the handle at the end. Gates can be turned on and off by clicking on them, and the value of a step is adjusted by sliding up or down. Speaking of the value, clicking on the trash icon will clear out every step to full value, and clicking again will turn them all off to minimum value. Let's plug this in and turn on a few steps. This slider right here adjusts the minimum value that the steps generate. Now if I turn these all back on, then this is the maximum that it can output. The dice button will randomize the sequence. The tie button will tie together consecutive gates. So 7 and 8 did not sound. Let's turn it off. And latch, if you look at the values right now, every time the next step moves forward, a value is output. If we latch it, only the value of, you could say, active steps or active gates is output. There is also a reset input. You can adjust the position where the reset begins from with this slider. Or with a connected number. When a position is changed, then any value at the right data input will be written to the sequencer. Watch the sequencer as new resets occur. Values are changed and written into the sequencer. So the sequencer can be used for pitch, it can be used to generate gate sequences. And it can also be used for velocity. Finally, moving on to the math and logic section, we are going to begin with the math functions. There are 2 of these modules, and they are identical. They have subtraction, multiplication, division, and then some specialized functions, which we will go over. Subtraction is quite basic. You subtract the right number from the left, and when nothing is plugged into the left, then you subtract from 0, creating a negative number. The other way to create negative numbers is with the invert module, which of course is useful for subtracting from some other value. Next up is multiply. This is an incredibly useful function. We already saw how to create valued triggers early on in this tutorial. And it is also useful for the envelope. Let's make a little example here to determine what the maximum range of your envelope is. I need to feed this a number. Oh, I just love that sound. Okay, this is also good for the oscillators, which also need to be multiplied up to unlock their range. And moving on to the wrap function. This is going to take a number on the right and a number on the left, and the left number cannot exceed the number on the right. It'll wrap around back to 0. So if this number over here is 37, then the number on the left cannot exceed 37. It is the same as the wrap on the counters. Next up is minimum. This will find the lesser of the two inputs, for example this 35, and forward that to the output. The lesser is 35, now the lesser is 32. 29, if I change the right, nothing happens until it becomes smaller than 29. Maximum works exact opposite to that. It will find the higher value and forward that out. Average will add the two numbers together and then divide them by 2. I haven't found really a function for this personally, but I'm sure somebody will. And last is percent. Percentage is very, very, very useful. What this does is, if I take the random output from this sample and hold and plug that in, and I make the second input of percentage 100, then 100% of what goes into this module will come out. You can see that the numbers are identical. But if I limit this, then only right now 50% of what goes in will come out. And now only 30% of this range will be output. As you can see, like the wrap function, percentage is good for limiting giant output ranges. And that covers all of the math modules. You will find thousands of uses for these modules. They are truly one of the biggest supports and utilities in Nest. Next up, let's take a look at the oscillators. These are not your typical VCOs from an analog synthesizer. They don't produce any sound on their own, but they are modulation generators. In order to unlock their full value, you need to multiply the value up. So let's give this one a range of about 34, and then send it to the pitch of the Minilog. A higher value range. Let's trigger it more quickly. We can increase its speed. And we can change its wave shape. Noise output random values within the range that is being multiplied by. It's a bit like the sample and hold in random mode. And pulse outputs a high and a low value at a regular interval. Geiger outputs a high and a low value at random but synced intervals. The Geiger and pulse oscillators are great for percussion. Let's make this a pulse. And of course, we can multiply this with the frequency modulation.